Section 7.4, Equations in Quadratic Form. So this section involves solving equations that don't look like they are quadratic, but actually they are quadratic, and we can, for the most part, solve them by factoring. So quadratic just means that you have ax squared plus bx plus c. So the important part is that you have x squared, x, and a constant, and that your equation is equal to 0. So the first two examples we can just solve directly through factoring. Your book uses U substitution. I'm just going to show you how to solve these directly through factoring because I think it's faster. So the first example has exponent 4 and exponent 2. So it doesn't really look like it's quadratic, but we can basically solve this equation the same way you would solve a quadratic. You can solve it by factoring. Instead of breaking down the first term using x times x, we're going to write, so this is just a regular trinomial. It's quadratic in form because y to the fourth, you can just write this as y squared times y squared, because when you multiply these two, you add your exponents and we get back to 4. We can use the same sign rules. These are both negative. And we need factors of 18. That will give us negative 11. So that's going to be 9 and 2. And then you can quickly check by foiling that you get back to the original trinomial, which we do. So now what we can do is y squared minus 9, that's a difference of 2 squares. You can factor that as a difference of 2 squares. Y squared minus 2 is not a difference of 2 squares, so we're just going to leave it like that, and I will show you how to solve. We want to set each of the 3 factors equal to 0. The first one tells me that y is negative 3. Second, y is 3. And then the third one, since we can't factor, what we do is just isolate y squared. You need to square root both sides. And when we square root both sides, you need to include plus or minus because there will be 2 solutions. So we get that y is equal to plus or minus square root of 2. And so we have 4 solutions. The same idea can apply for the second example. When you are solving the equations in this section, you do need to have a 0 on one side. So the first thing is subtract 50 to get 0. Next, this is quadratic in form because if you look at this carefully, see how we have x plus 7 squared and we have x plus 7. So instead of just having x squared and x, you have x plus 7 squared and x plus 7. So this is quadratic in form, but just not in terms of x, in terms of x plus 7. You can solve this by factoring directly. Let me show you. Just think of this as just a regular trinomial. And in order to get x plus 7 squared, we need to have x plus 7 and x plus 7, because when you multiply these two, we get x plus 7 squared. The same sign rules apply. Signs will be opposite. One will be positive, one will be negative. We need to find factors of 50 that will give us positive 5. So factors of 50, we can use 5 and 10. 10 should be positive, 5 should be negative. So this is factored. Notice that we have like terms. We can actually combine those. So this is going to give me x plus 17, and the other one is going to give us x plus 2. From here, we solve like we normally do. Set each factor equal to 0. X is equal to negative 17. X is equal to negative 2. So in this case, we have two solutions. Let's take a look at the next example. So this example is actually a little bit more complicated. For this one, we should use U substitution the way that your book shows. It's not as easy to factor this directly. You can do it, but I think it's easier to use U substitution. So let me show you how that works. So basically what you're going to do is we're going to use the letter U. And we're going to say that U is equal to the variable part of your middle term. So U is going to be y to the power 3 over 2. Then we're going to look at this equation that we just wrote, and we're going to square both sides. So you square U, you get U squared. When you square the right side, 2 will reduce, and so you're just left with y to the third. Okay, so really quick, when you square, okay, you square both sides. Exponent rule is you multiply, so these will reduce and we get y to the third. This will be what we use for substitution. Let's go back to this equation. I am going to replace y to the third with u squared and y to the 3 over 2 with u. Why are we doing this? Because it makes the equation look quadratic and easier to factor. So now this equation is much easier. We know how to factor. We know that it's u. Signs are both negative. The only way to get negative 28 is to use 27 and 1. Set each factor equal to 0. Solve. Okay, so one thing that you need to remember, we are solving for y. Since I used substitution to rewrite the equation in terms of u, once you get to this point, we need to resubstitute so that we can solve for y. We don't want to leave the problem like this because you're trying to solve for y, so you have to do a few more steps. So what we do is just go back, use what we wrote here. We're going to resubstitute, replace u with y to the 3 over 2 power. Same thing over here. And we need to solve, basically what you have to do is solve for y to the first power. What we need is we're going to raise both sides to the reciprocal 2 over 3. Okay, why are we doing this? Because you need to solve for y. The only way to make this exponent 1 is to multiply by the reciprocal, which is 2/3. When you multiply your exponents here, we can reduce and we just get y to the first is equal to, this is really cube root of 1 squared. Cube root of 1 squared is 1, so that is a solution. Same thing here, we get y to the first, or just y, and this is cube root of 27 squared. Cube root of 27 is 3. So that's going to give us y equal to 3 squared, which tells us that y is equal to 9. And so we have our two solutions.